just going to weld some stainless tube just to lay a bead. We're not trying to make anything necessarily. It's just we have laying around here. But it gives us also an opportunity to talk about, you know, prepping the steel a little bit. In TIG welding, unlike MIG welding, it's a little less forgiving. You'll want to make sure on stainless that you have all the oils removed. On an extra dirty piece of stainless steel, you can hit it with acetone first and then follow up with denatured. You don't really actually have to follow up with denatured alcohol, but I've done some experiments where acetone's great to get the crud off, like all the built up scum off of the steel, but it sometimes just smears oils around and doesn't get the oil film up as well as denatured. So I always, just out of habit, will follow up with some denatured alcohol to get the remaining oils off. Sort of first came across this when prepping for auto body paint. Okay, and of course follow up with your filler rod too. All right, so what we're going to do is just simply lay a bead. I've got the machine set to 50 amps, thank you, which gives me a little bit of headroom. I think the wall thickness is roughly 48 thousandths of an inch. A good starting point that I've always read about and heard about is about 1 amp of machine heat per thousandth of an inch of material you're working with. This is about 48 thousandths. I'm going to run at 50 amps, and that's without pulsing. Okay, things change when you start running the pulser. You actually, your actual realized amperage in your parts, an average of your peak and background, and so you're not actually getting 50 amps if your peak is 50. You know, it's whatever the combination and ratio in between is, or mix of. Okay, so let's see. I'm just going to go ahead and before we strike an arc, I'm just going to talk about holding. I'm not going to strike an arc, so you don't need to lower your shields. But torch angle is pretty important, and what also is important is the distance away from the top of the workpiece that your tungsten is. I like to try to keep about what would the equivalent diameter of the tungsten, in this case 3/32. I think that's about 2.4 millimeters off the puddle. That's a good starting point. You know, closer the better is better. Closer is better. Try to get as close without just jamming the tip of your tungsten into that molten puddle of steel. What that effectively does is it narrows the heat band that you're imprinting onto the steel. And in the case of stainless steel, you don't want to cook your stainless steel. You want to be able to have good gas coverage, move fast enough that you don't put too much heat in the stainless and cook out all the good parts, the anti-corrosive, I guess, qualities of stainless steel. And so, talk about angle. Vertical's awesome, but it's not as easy to see. So, cocking it back a few degrees is a good way to be able to ensure that you're not going to jam the tungsten into the puddle, and also that you're not going to jam the filler rod into your tungsten. Don't worry, you're not going to shock yourself, not with this low of voltage. If for some reason you're sweating and you do feel a little bit of a bite, it's not going to be anything that will make you grit your teeth or anything like that. Obviously, don't be sitting in water while TIG welding, though. Public service announcement. Okay, so we want to try to work quickly, which means we're going to want to travel as fast as we possibly can and dab in filler rod as fast as we possibly can to keep the puddle full enough to the point where when we move forward, we're pushing the puddle forward. Okay, so on mild steel, it's much more forgiving. On stainless, it's not. And Michael can attest to that. He's learning to weld on stainless right now, and it's not the easiest thing in the world, but once you master it, it's great because you make beautiful furniture, and that's kind of what we're here to do, most of us. So I tend to have this type of relationship. You should be able to get your puddle established within the first 1 to 2 seconds. So as soon as you turn your hammer down on the pedal with your foot all the way, you should be able to have that puddle established within 1 to 2 seconds. If it takes longer, you're not hot enough, which means you need to go from 50 amps to, like, say 55 amps. Try again. If that still doesn't go, up another 5 amps. So the whole 1 amp per 1,000th of an inch is a starting point. It's a point of departure, if anything else. Start there and then adjust. If you hammer the pedal down and immediately blow a hole in your part, go the other way. Run cooler. So go from 50 down to 40 amps or 45 amps and try again. One thing to note is if you do a lot of welding in the close proximity of one piece of tube or flat bar, what worked when you first started welding at 50 amps is going to run and feel, and it'll be as if you're running at 65 amps by the time you get towards the back, because this holds heat. Especially stainless steel. It's infamous for being a heat sink or heat tank, I should say. So I think we're ready to hit pause, and then we'll get to welding real quick.